Hello and welcome to the lecture 1 of the Learning About Learning lecture series in this NPTEL course. And in the, as I was talking to you in the introductory lecture or the introductory brief video, we will be learning a lot about learning itself, the phenomena of learning, how it is existing or came into existence in organisms, and how we can study it, what we can understand from how we learn and how those learned information is stored in the brain. This notion of learning interested many people, interests you and me, and it interested very many people. And one of the first to actually study and propose any mechanisms and to study this learning in a systematic manner dates back to a German psychologist called Hermann Ebbinghaus. He argued if learning were to happen, one of the prominent manifestation of that would be our ability to store the learned information. So, we should be able to see or experience this learned information in terms of what the storage of this information, we call it as memory, and he wanted to study that. Okay. That is Hermann Ebbinghaus. And how did he decide to study it? He decided to study it through experiments on himself. It is called introspective experimentation, and what he would do is that he would make word lists pretty much like if you are actually preparing for any competitive exams where you would want to remember many things, and these are new things. Then what you do is you make small cards like small chits where you write what we call it as cheat codes, or where you write what the new information is, what the new word is, either the meaning of it, how you use it, or a definition of it, and so on and so forth. Pretty much like that, he wanted to make a list of words. However, he was very much aware of the fact, if I am going to start and test memory, then I need to start with a clean slate. What do I mean by clean slate? A brain which does not have a previous any information related to this that I am actually going to try to learn and store. Okay. If I want to put it in a perspective, so if I am going to learn about a cat and ask how well I remember what I have learned, then it is that much more helpful, and in fact, I want to make sure that I do not have any information about the cat before. If I do have, then it is going to bias what I am learning about the cat. So, how would you start with a clean slate then? Because in adults, as in with many humans, when we are doing the experiments, this can be very hard. So, the way he did that is that he ensured the information that he is going to learn is new, even though he had many more related information like any adult would, that to a psychologist. Definitely he has a lot more information that he has acquired over his life, but what he can do is he can zero in on the informations that are not familiar to him before. So, what he would do is that he would make something called as a triad. These are 3-letter words. He would choose the triads such that they follow a particular format. We call them as CVC triads, consonant, vowel, consonant triads. These are rare, not to say that they will not be there at all in any language, but they are rare in general. So, an example would be DAX, CAT, cat itself. So, like that he would form a 3-letter words, a long list of them, and then he will go ahead and strike out those dictionary words. Dictionary words are those words that exist before, like for example, cat I told you, bat, pot, all of them he would actually strike them out and then leave only those words that does not exist in the dictionary, and in fact, he was so careful he would even go ahead and strike out any word that has a resemblance to a dictionary word. Thereby, he shortlisted about 1,000 or so triads. I mean, write them in a sheet of paper, put them all in a basket, pick one at a time and read out aloud with a monotonous voice without any modulation. The idea here is I am going to read this word, memorize it, try to memorize it, or in the here what you are doing is you are trying to acquire that memory or learning about that word, learning the word, not about that word, just the word. Then he will ask how many of these words in the word list, in the list of words that I have decided to that I had picked up today, right, in this experiment. So, there is a basket, in that there are a lot of sheets with these triads. I am picking one after the other and then each time I am reading it aloud. I now made a list that I have picked out today. Later, at later point in time, he would actually come back and then say how many of those words that I picked out I am able to remember. So, that is the first kind of a question that you would like to ask, right, because the idea of learning requires that you need to be able to store information that you have learned. The idea of storage tells you that you would be able to retrieve those information later in time. That is how you can test how well you are actually able to remember. So, if what he did was he went ahead and plotted this remembrance, fraction of the words that he was able to retrieve from that list as a function of time. The fraction of the words would relate back to remembrance. When he did that, what he got was this wonderful little graph which is known as the forgetting curve. So, what he has plotted here is that memory retention as a percentage. Essentially what he is doing here is he is measuring the fraction of the words that he was able to recollect, fraction of words recollected. As a function of elapsed time. This is the time that is elapsed between when he initially pulled out these words from the basket to the time at which point to the time of testing, when actually he is testing it. Okay. So, from this what he was from the graph what he was able to see is that there are words that are lost very quickly, very quickly, right, like within a day or so you are actually losing them. There are some that are lost over a period of time, but there is a constant fraction, right. Remember, this is non-zero. There is about 20% of them that you never forget at all. So, a set of words that you lose just then and there, a set of words that you lose gradually, and a set or a fraction about 20% that never gets lost. Just by doing this very simple introspective experiment, he was able to come up with very important aspect of memory, that is there are multiple phases in which the memory could be retained. He called those words or those fraction of words that stayed until the duration of the task and little around that time, he called that as immediate memory. In the present day we call it as working memory. The definition is those memories are those details which we are able to retrieve and stays there with us until the duration of the task. Once you are out of this task, then it is harder for you to retrieve them. Second phase called as short term memory, and these are the in between guys. So, these fractions of words were staying with him after the task, but not like the other guys which stayed forever. They would eventually decline, but they were able he was able to retain them for some time, some duration, which is larger than the task duration itself. Hours to days one would like to say, but that is the short term memory as we know in the modern terminology too, and important fraction, the long term memory, that is the memories that last for months to years. This is the 20% fraction that we saw in the graph. Now, this idea or this notion that memories can be classified into 3 different phases, and just by looking at the lifespan of it was phenomenal, but this notion of postulating the nature of memory and going ahead and testing it, right, that kind of set the tone, designing an experiment around learning and memory. So, how do we design the experiments? If you look at this carefully, if you study this carefully, you can think of this whole experiment consisting of multiple kinds of blocks of time, blocks of period or phases of experimentation. The first phase, the number 1 phase, you can think of as a pre-training phase, second followed by a training phase and then a testing phase. So, the pre-training is the time where you prepare for the experiment, in the sense you need to make ground rules, you need to familiarize yourself about the task, such as okay, I am going to take this chit out from this and I am going to monotonically read it without any voice modulation. So, that takes some practice. So, that you do not leave any other clues to your brain that can aid in memory, right. So, you are testing a particular aspect of memory and you want to just test that and nothing else. So, like that even today when we are doing these experiments in animals, this notion exists. So, where we need to make sure these the animals are familiarized with the task. We do that through a process called habituation and of the animals, and it also has to do with the fact that when you are testing when you are handling the animals should not freak out just because some external, some other organism is actually trying to lift it up, and it does not, you do not want them to be anxious. So, you handle them, you habituate them, and then the idea here is to train them in a task, so that you can later on go ahead and test it. That is the notion of pre-training, training and testing. So, the pre-training allows you to set the ground rules for the task that you wish the animal is going to you wish the animal is trained for or learn, the animal is able to learn. Say for example, you are going to make the animal learn a task where the food is a reward. So, then one of the important thing is to make sure that the animal is wanting to eat the food. So, how do you do that is you make sure that the animal is on a clock for the food. So, there is a schedule that is put on for the animal. Normally in a lab setting, the animals eat the food at will. So, there is no particular schedule. So, now you can impose a schedule such that they are expected to eat the food in a defined time period. If they do not eat it, then they will not get it. So, as a result, there is an value for the food that is given during the experimentation. So, all these things are done during the pre-training phase. The training phase is really the phase where you are presenting a task in which the animal learns to perform it. once during this process you can devise a metric through which you can measure the performance and you follow the performance. Once a set performance level is reached, then you can go ahead and test the animal how well the animal has learned this task. Testing really is about testing the memory of the training that they have that you have imparted into the animal and what they have learned and how well they are actually remembering on the task itself. By analyzing the animal's behavior in these 3 different phases, one would be able to dissect out the various aspects concerning the learning and memory itself. And that is if you look at the entire course, every single experiment that I will be describing to you and the inferences that I will be drawing, you would be able to generalize into these 3 different categories, these different blocks. Am I looking at the pre-training period, looking at the training period, or maybe I am looking at the entire the behavior in this entirety ranging from pre-training, training to testing. Let us do that with a very simple example here. So, we know that Hermann Ebbinghaus did his experiments on himself to show that there are 3 different phases of memory. Today, thanks to multitude of experiments done on lab animals, human beings and several other conceptual advances, we know that we do not have to make this definition of these phases like the short term, immediate and long term in a heuristic manner, right. He just looked at the curve, the decay curve of the memory retention and then said, hey, somebody is decaying faster, somebody is little slower, somebody does not decay at all. So, let there be these 3 phases. We do not have to do that. We can actually more objectively approach this problem and try to ask, are there different substrates, are there different ways in which these informations are stored in the brain? If so, can we go ahead and test it? And we know they are stored in different ways. I am going to describe an experiment to demonstrate that they are stored in 3 different ways. I am going to use this paradigm pre-training, training and testing to actually accomplish my task. So, how do we do that? Let us start with a group of animals and so the idea is, remember, we are going to define the 3 different phases of memory in a much more with a much more stronger physical basis, all right. So, first what we will do is that we will train these animals in something called as a context. Okay. So, the idea is that the animal needs to remember the context. We are going to test it. So, there will be different measures of performance during the training and testing. So, let us not worry about the measures as of yet now, but let us look at the notion, let us look at the bigger idea of testing this memory at different points in time or through different interventions. In this particular case, I am going to be doing both interventions as well as through different points in time. One of the hypotheses thanks to the research that I talked to you about is that for you to remember for a long period of time, remember the 20% fraction that I was talking, the equivalent of that, our research show that protein synthesis, de novo protein synthesis is essential. If you block it, you will is essential. Without that, you will not have this long standing memory. So, the immediate task that we would like to do is to, let us say somehow we block this protein synthesis, then does the memory not that do we not see this 20%, do we not see this long standing memory. Okay. So, that is the question that we are going to ask. So, to address that, let us look back at the design. So, first group that we would like to do is that, okay, hey look, I am going to train this animal to remember a context and then what I am going to do is that I am going to infuse, I am going to intervene with an infusion of a drug called anisomycin, that is this. So, this drug is known to stop the protein synthesis. I am going to infuse this drug right after the training, okay, and then test in about 30 minutes. Okay. So, we have trained, hopefully the memory is formed, and we are going to infuse this drug in 30 minutes, we are going to test it. Just by looking at the performance here, we know if the memory is formed, and if it is formed, how well it is formed. Then we are also going to test it 24 hours later, right. Why is that important? This is important because see what we are trying to show is that we are going to test is that protein synthesis is important for retaining the memory for a longer period of time. That is the idea that we are going to test. The way we are going to test it is using this notion of training and testing. Pre-training is done such that the animals are being handled by the experimenter and they had to be injected. The act of injection should not cause any such disturbances such that they get freaked out, they do not express the memory. So, you do not want to conclude because of this you have you are seeing a deficit in memory. So, you do that by two means. One, you really make sure there is a habituation phase where and handling phase where you are training the animal and making sure that they are not freaked out with the experimenter. However, for injecting itself, injecting the drug itself and doing this on the experiment day, you really want to have something called as a control group, wherein you inject everything except the drug, because see the drugs are usually dissolved in a vehicle, it is called saline in this case, and you are injecting that the drug plus the vehicle into the animal. So, what you can do now here is that we do not inject the drug, but we just inject the saline alone. So, that would be a very good control. If it is the drug that is actually causing the stoppage of the protein synthesis, as a result you are failing to see the memory strengthening over or retention of memory over that period of time, then this group wherein you do everything exactly the same except for the drug. There is no drug here, you are injecting the saline, the vehicle, and going forward with exactly the same things that you have done in this group. Then by comparing the performance of this animal at these different points, they are equivalent time points, right, they are equivalent things except for this drug. So, by comparing these performance, you can actually conclude what role protein synthesis actually plays. Similarly, so that that would work to test at which point in time the memory retention is actually failing, it is giving up, right. You can also do something else in here just to stress on the point, and another experimental group wherein you infuse a drug called AP5 or CPP. These are called as this come under a special class of drugs. So, anisomycin is protein synthesis inhibitors. These are receptor blockers, okay. More particularly it is NMDA receptor blockers. Their function is different towards, I mean, as we go along this course we will understand these functions better, but we will not right now you do not need to know about what these functions are. All we need to know is these are two different molecules, molecule A anisomycin, molecule B AP5, and there is a third group where we just infuse something on which these two molecules are dissolved. Then what we are going to do is that we are going to test them at two different times, 30 minutes and 24 hours later. If you do that, what you see is that the memory retention okay, when you measure right after the training, okay, they are all equal. So, all the 3 groups are would perform equal. Okay. However, if you were to measure them 30 minutes post training, okay, give a gap, take them out, okay, and if you do that 30 minutes later, you will see that the AP5, this group, the third group will not have, will have an impaired memory, while the other 2 are as good as the memory that will perform as good as when they were performing right after the training. Of course, when you do it, you also want to have 3 different groups for 3 different time points, that that is a bit of a detail. So, what you are talking about is that this group of mice on an average would also perform similar to this group of mice that is tested very much close to the training, right after the training. Here is the peak of the experiment, which is if you were to test 24 hours later, only the saline group will show the retention of memory. However, the both anisomycin, we call it as molecule A, and AP5, the molecule B, both those groups would show no retention of the memory. So, this guy did not have the memory even at 30 minutes. So, he continues to not have this memory. This group, right, they were having memory at 30 minutes. However, 24 hours later they do not exhibit any memory retention. Clearly, the drug or the molecule that we infused prevented the animals in forming these long standing memories. That molecule is different from the molecule that is capable of blocking the formation or the acquisition of the memories themselves, because initially they were having and these guys are not having it, and it is nothing to do with the training. You can train, I mean you can train them, that is not happen any different way, and all 3 seem to be at a normal levels. Now, that is a formal way of dissecting out different phases of memory. Now, you can clearly see this involved pre-training phase, where we made sure that the animals are handled and be comfortable and they are not anxious, and there is a training phase where we are making the animal learn that something is been taught, context A in this case, and then we are testing. In between we are intervening with different drugs. Now, that kind of phenomena, that kind of notion of an experimental design is what I was talking to you about. Pre-training, training and testing phase defines many of the experiments that we do in our learning and memory field, and just by using this kind of experimental design we would be able to elucidate lot more informations. Example 1, we are continuously talking about storage of an information that has been acquired, that has been learned, right, that is resultant of a learning or a training task. First thing that you want to ask is, if something is stored in the brain, then can we zero in on where exactly is that being stored. So, Lashley started to ask such questions. The way he did that is he took rats and then trained them in this task, a maze task. Maze is just a big device where you are letting the animal go, the animal goes in, and then the animal has a choice of making a left or a right turn, of which one of them is a correct turn. The correctness is defined by its ability to follow that path, follow a path to a goal box. So, a start box, if it makes a right turn, it will lead you closer to the goal box, while the left turn will lead you to a blind spot. So, if you keep on doing that then what and then making the correct turns, then in a shorter period of time, I mean without making much of the wrong turns, you will be able to make the reach the goal. By measuring how many wrong turns the animal is actually making before reaching the goal, you can actually monitor its performance. His task was, okay, now I am going to take these rats and then train them in this task and measure their performance. Measure their performance as a function of what? I am going to actually perform lesions, cortical lesions. So, he would actually open up the skull and remove a portion of the brain in the rat, and the rat survives, no issues there, and then ask the animal to perform. The idea here is, if there is a region in the brain, and if I am a region in the brain that is storing this information, if I am actually progressively increasing my lesion volume, at some point I am bound to hit that region. Until I hit that region, the decrement I should see in the performance should not be much, but once I hit that region, there should be a sudden change in the performance that I see, because just I remove that region, I have removed that memory. Now, the animal should not be able to perform this task, should not know which is the correct turn and which is the wrong turn. It should make as many errors as it used to make during the start of the training. That is a fantastic idea and fantastic notion, but what did he see? What he saw was there was no such drastic change. Granted, the progression, the decline in performance that we are plotting, that he was plotting as a function of the lesion volume, right. So, remember, please note what he is plotting here is error. So, if the higher is the error, lesser is the performance. So, if you see a curve going up, the animal is performing lesser and lesser here. What he is seeing is that as he takes away more and more volume, the performance gradually goes up. There is no sudden change. It is nonlinear, but there is no sudden change, leading him to conclude, no matter whatever I do, it seems as if there is no structural place where this learning seems to be stored, which means learning should not be possible, even though behaviorally I can see the expression of such thing. It was a very depressing note, particularly if I tell you that this whole experiment he did it many more times with a lot more different variations. He spent about 30 to 35 years of his time trying to localize the memory. He summarizes all his exploration in this wonderful monograph called In Search of N-gram, and then that is the conclusion he was able to draw. Thankfully, there were many more researchers who were also trying to find or localize memories, though coming from a different angle. The angle ranges from his one student Donald Hebb. He is known for several other things, but one of his major contribution is that to explain Carl Lashley's result. What he said was that, hey, look, this may not look surprising if you think that memory is not stored in one simple place, but it is stored across multiple assemblies. It is like it is stored distributed in a distributed manner. So, if you say it is stored in a distributed manner, then so that is the keyword here, distributed memory storage. Then if you are removing a component of it, there is sufficient amount of other things are present helping you to actually retrieve the memory. As a result, you may not see that all of a sudden change. Of course, it brings another point how cooperative are these individual informations, but the message that he is trying to convey is that there are reasons why you may not see it, and it may be fallacious to think that all the memory is stored in one region. Maybe that is why Carl Lashley was not able to localize these memories. Currently we do think, at least in the cortex, the memory is stored in a distributed fashion, and and then more interestingly, not all of them take part equally, we do know that, and then if you remove them you may see the degradation in to various extent. But the reason why he did not see, he saw a monotonic, well, Lashley did not see, ranges from various aspects, ranging starting from the complexity of the task, so on and so forth. So that besides the point. The current view is that it is distributed, at least in the cortex, but if that is so, isn't there, I mean, if that would say that, okay, there is no one unique, I mean one unique place that where you can actually go ahead and localize these memories. All along this time, there were interesting studies that are happening that involved human patients. Thanks to Wilder Penfield, a neurosurgeon, what he developed was an interesting and essential technique for zeroing in on regions that are causing epilepsy in human patients. So, epilepsy is uncontrolled seizing behavior. So, what he would do is that in those days, to cure this epilepsy when it is going at a debilitating stage, is to go ahead and remove that region of the brain, even in the humans. So, you can't go and then remove arbitrary amount of regions without knowing what these things are going to do. So, there is a cost associated with it. So, what you will do is that any technique that can zero in that can help you to zero in on that particular region would be of very great use. So, what he did, Penfield did was to arrive at one such method. He would take an electrode, it is called a microstimulating electrodes, and he will inject a small amount of current looking at the response of the patient. Idea there is that if you are hitting on the region which is causing epilepsy, then you will be able to quickly zero in on that, and then if there are regions where you do not elicit a response, seizure kind of a response, then you can leave them safely there and without disturbing them. In doing so, he made some remarkable findings. One is that he said he was able to map what these different regions of this of human brain, and he was able to topographically map what these different regions of the brain do, and more importantly, when he was localizing his microstimulation on this particular lobe called as medial temporal lobe, he was able to elicit past lifetime events in many patients, in about 8% of them, suggesting possibly these are the regions that are storing this memory. So, this is the exact reverse of Carl Lashley's experiments, right. He was trying to remove a region and seeing the decrement in the performance. He is now in here, Wilder Penfield is trying to stimulate a region, activate a region, brain region, and see what behavioral response it can actually elicit, and that is what he saw. However, the interpretation of these results were hard mainly because he was working on abnormal brain. So, that due to epilepsy. So, how do we what do you mean by enacting the lifetime event? And then to make the case worse, 40%, about half of the persons who were able to retrieve, whom he was able to help them retrieve the old time memories, they experienced they had same experience during their epileptic episodes too, leading people to say, hey, it is really hard to actually say if it is this region that is storing the memory. There is an inclination towards this region, there is a clue towards this region, but it is not proved. We can't prove that that is the region until the patient Henry Mollation, HM, abbreviated as HM, came in. Chauvel and Milner, Brenda Milner, operated on HM and then for epilepsy, and sure enough, after the operation, after the removal of medial temporal lobe in HM, his epilepsy was under control. However, during this process they noticed something peculiar. The doctor who operated on HM had to introduce himself every day through the entirety of HM's life after the surgery. HM would not be able to remember and recognize who this person was, despite the fact the doctor was introducing himself again and again and again. Even though he would remember his name, his childhood and his family, everything else, as much as you and I remember, right. We all have a progressive decline in our memory to some extent, right, just like Ebbinghaus's curve, where we do lose some amount of memory, but retain a good fraction of them. He was able to retain them, there is no problem with that, but his ability to form new memories was severely impacted, giving us the clue that probably what Carl Lashley failed to find, we might have found in this human person. And why could that be the case? Why did he fail? Why did Carl Lashley fail while Chauvel and Milner were able to zero in on this region and then say that there is a memory deficit, ability of the person to form new memories is lost? How is possible that? Is it the difference that the rats have a different notion of memory, different way of storing the memory, while the humans have it different, or something else? To understand that, let us look at the anatomy of the brain itself. If you look at the anatomy of the brain, so what I am showing here is a section of the brain where the nostrils, if you place the rat, the mice or the mice brain such that the tail is projecting away from the screen and the nose is projecting out, then if you take a small cross section of the brain, that is how it looks. And Carl Lashley would go ahead and remove the outermost part of the brain marked here in this black lines. These are the cortical regions, and his lesions were on those regions. However, the equivalent of the medial temporal lobe in the rat is that, the hippocampus. Now we know if we were to remove this region in an animal, the animal would exhibit similar loss in memory. So, where his experiment failed is that he was operating on wrong regions for the task that he was training the animals in. That is why he was not able to zero in on. However, the findings he had that different amounts of cortical lesions affects the performance in a nonlinear manner, but I mean in a progressive manner still stands, and the conclusion that the memories are cortical dependent memories are stored in distributed fashion is true till today. But the point here is the memories that we are interested in, the memories that one can consciously recollect at will be lost if you remove hippocampus, just like in HM. When they removed medial temporal lobe, they made him HM developed a class of amnesia called as anterograde amnesia for new memories. With that, I will finish this lecture 1, and thank you for listening, and I hope to see you in the lecture 2.